Today we are learning about the common factoring of polynomials. So let's recall that we use the distributive property to multiply a monomial through a polynomial. So if we look at the example we have here, you can see that we have a monomial out front and a polynomial in the brackets. And to get their answer, they used the distributive property by multiplying the 3x times each term within the brackets. And they got this final answer. So with the distributive property, I'm going to teach you guys a new term called expanding, and that means that it is another name for an operation when the distributive property is used. So if you were to get a question that said, expand this set of polynomials, you would essentially use the distributive property. So expanding and distributive property go hand in hand. You've just learned that expanding takes us from the left side of the equation to the right side in this example. And now if we introduce the term factoring, it's actually the opposite of expanding. So it takes you from the expanded version into this version, which is known as the factored form. So in our list here we have expanding and factoring. Factoring works the opposite direction of expanding, and it is used to simplify a polynomial by writing it as a product of its factors. So as you can see, up here we've written this polynomial as a product of its factors. Today I've taught you two new terms, expanding and factoring, and we know the two are essentially opposite. So factoring takes us from this side to this side, so kind of the more involved version, and factoring takes us from the more involved version down to the simplified version written as a product of its polynomial factors. So in order to figure out the factored version of a polynomial, it's important to introduce this term, greatest common factor, or GCF. So that is the largest number and variable that is common between each term in the polynomial. So for example, if we have a polynomial that is 4x squared plus 2x, to find the greatest common factor, we need to look at both these terms and see what the biggest number is that they can both be divided by, and as well look at the biggest number of x's that is present in both terms. So my number for my greatest common factor would be 2, because that's the biggest number that 4 and 2 can both be divided by, and my greatest common factor in the variable part would be just x, because they both have at least one x. We can't pick x squared because this does not have an x squared that we can take out. So as a result, the greatest common factor of this polynomial would be 2x. Again, greatest common factors are helpful when moving from the expanded to the factored form. So let us work through an example that deals with factoring polynomials. So I've written the steps here. First, you want to find the greatest common factor. So we need to look for the biggest number that 12 and 8 can both be divided by, as well as the greatest variable that is present in both of the terms. So in this case, our greatest common factor numerically between both terms is going to be 4. And in the variables, it's going to be x squared. And that leaves us with our greatest common factor of 4x squared. So this 4x squared is essentially what we can pull out of our original equation, 12x cubed minus 8x. So we would rewrite this as follows. 4x squared times 12x cubed divided by our greatest common factor, because this will essentially take out the 4x squared from that original term, minus 8x squared, also divided by the greatest common factor. And again, this will essentially pull out the 4x squared from the 8x squared. And then we simply go about and do our division. So by quotient rule, 12 divided by 4 is 3x 3 minus 2, and then 8 divided by 4 is 2x 2 minus 2. And again, we'll simplify this further. 3x minus 2 to the 1. Again, as an aside, I'll just remind you that x to the 0 is equal to 1. And then we round this out with 4x squared bracket 3x minus 2. And that is our factored version of the polynomial above. Let's go through another problem. So if we were to factor this polynomial, the first thing we need to do is find the greatest common factor. So again, let's look for the biggest number that both the number coefficients can be divided by, as well as the biggest value of x and y that can be taken out from both terms. So right away I can see that the biggest number that both 18 and 27 can be divided by is 9. I can also see that in terms of our x's, we have an x2 and an x6. x2 is our greatest amount, so we'll pull that out. And between our y's, our y to the 5 and y to the 3, our greatest number that they both have is y to the 3, leaving us with the greatest common factor of 9x squared y cubed. Now that we have our greatest common factor, we move on to our second step, which is rewrite the polynomial as a product of the greatest common factor by dividing each term by the greatest common factor. So moving on to step 2, let's rewrite this polynomial as a product of the greatest common factor by dividing each term by the greatest common factor. So we rewrite this with our greatest common factor out front, and then we write each term divided by that greatest common factor. So 18x squared y 5 divided by 9x squared y 3 minus 27x6 y 3 divided by 9x squared y 3. And again, we divide each term by the greatest common factor because it essentially pulls out that value of the greatest common factor. So our next step is to proceed using the quotient rule. So 18 divided by 9 is 2. X squared divided by x squared is x2 minus 2, which is 1. And y to the 5 divided by y to the 3 is y5 minus 3, which is y squared. And then 27 divided by 9 is 3. X to the 6 divided by x to the 2 is x6 minus 2, so x to the 4. And y to the 3 divided by y to the 3 is y3 minus 3, which is going to be 1. And our final step is just simplifying. So 9x squared y3 times 2y squared minus 3x to the 4. And again, that is our factored form of this polynomial.